welcome to Mathematics class. By the grace of God, today we shall be looking at a particular topic in mathematics called angle. By the grace of God, I will give you the definition of angle, the types of angle, the properties of angle, and some of the theorems that we have in angle. Then we will face some workings in angle. I want to tell you very quickly that whether you are preparing for an external exam or an internal exam, what you need is to please listen keenly to every part of this video. If you are confused in any aspect, pause it and play it again. God bless you. Let's start. Angle can be defined as a place where two or more lines are joined. When we talk about angle, we talk about a place where two or more lines are joined. And please listen, I didn't say join together. Why? Because when you join something, you have already put it together. So for you to say join together, you are speaking tautology. So please take note of that. So angle, I repeat, is a place where two or more lines are joined. If you look at our God very well, I'm talking about the living God, the creator of the heaven and the earth, you will discover that he's a mathematician. He formed a kind of mathematics in our body, a lot of calculations in our body. Now, if you look at my hand, be stretched now. You will discover that there is a line here. This is a straight line. This is another line coming from this place. And this is the place where the two lines are met. So this is an angle. The moment I bend this thing like this, so I have my angle here. Same thing on the board. If you look at the board, this is a line. This is another line. Where these two lines are met is called an angle. And that's where we have our theta. Then we proceed to what we call types of angle. Majorly, we have four major types of angle. And the first one is acute angle. What is an acute angle? This is an angle less than 90 degrees. Now, if you look at the board very well, you will discover that we have a line here, we have another line here, and we have theta less than 90 here. This theta could mean anything from 0 to 89, but it must not up to 90 degrees. It could be 0, it could be 1, it could be 10, it could be 20, it could be 40, it could be 60, it could be 70, it could be 80, it could be 84, it could be 85, it could be anything less than 90. So let's move to the second type of angle, and this is what we call right angle. A right angle is known to be 90 degrees. Define it to be this is an angle equals to 90 degrees. Now look at this. This is a straight line. This is another straight line. Now if you look at this vertical and this horizontal. Now you see a sharp angle here. Sometimes when we enter into calculation, you will discover that we will not have that time. Sometimes they will give us a question that they will just put this in without the value. Then always note that that thing is 90 degrees. So any right angle is known to be 90 degrees, and that's why we are having it here to be theta equals 90 degrees. Now we move to the third one, and this is what I call obtuse angle. Obtuse angle. This is an angle greater than 90 degrees but less than 180 degrees. So what am I talking about here? When we talk about obtuse angle, we talk about an angle greater than 90 degrees but less than 180 degrees. And from the board, you will see that we have a line here, we have another line here. Please take note. You will discover that when we are talking about right angle here, that one is straight, but this one has been bent a little. So that is to tell you that it has exceeded 90 degrees, but it's not up to 180. And that is why we are having it to be theta greater than 90 degrees, but less than 180 degrees. So when we talk about obtuse angle, we talk about an angle greater than 90 degrees, but less than 180 degrees. So we move to the fourth one before we go to properties of angle. The fourth one is what I call reflex angle. Reflex angle. What is reflex angle? I define it to be an angle greater than 180 degrees, but less than 360 degrees. So if you look at the board very well, you will discover that this is a very big angle. It's almost forming a circle, but it's not, the circle is not closing. So from here down to this place is what we call a reflex angle. And the reflex angle is greater than 180 but less than 360. So that's why you see theta greater than 180 but less than 360 degrees. So that is all about the definition of angle and types of angle. Let me quickly wrap it up under that area before we go to properties of angle. What are we talking about? The first phase is talking about the definition of angle and the types of angle. And I told you that angle is a place where two or more lines are joined. And then I told you that we have four major types of angle. We have what is called acute angle, which is an angle less than 90 degrees. We have right angle, which is an angle equals to 90 degrees. We have what is called obtuse angle, which is an angle greater than 90 degrees but less than 180 degrees. And we have what is called reflex angle, which is an angle that is greater than 180 but less than 360. God bless you. Let's quickly move to the properties of angle. We have three major properties of angle, and they are corresponding angle, alternate angles, and vertically opposite angle. I'm going to give you the third one shortly after these two. Now, listen please and listen keenly. Listen and listen keenly. What am I talking about here? If you look at the board very well, you will discover that we have this property like this. Please pay attention. We have these properties like this. We have a straight line here. We have another straight line here. Now listen please. Look at this line. This line is called transversal. The moment you see a straight line crossing parallel lines, we call that line transversal. We call the line transversal. And once a transversal line crosses parallel line, then these three properties are certain. Number one, corresponding angles are equal, vertically opposite angles are equal, and alternate angles are equal. Now look at the board. From the diagram above, we have a line here. We have another line here. Please pay attention. Here we have above, below. Here we have above, below. When we come to the left hand side, we have above, below. And down here we have above, below. Please pay attention. Now, whatever this above is, that's what this above will be. Whatever this below is, that's what this below will be. Whatever this above is, that's what this above will be. Whatever this below is, that's what this below will be. That is what we call corresponding angle. Now, if you look at the board, A is above the line and E is above the line. That's why we have A equals E. B is below the line and F is below the line. That's why we have B equals F. We have C below the line and G below the line. That's why we have C equals G. We have D above the line and then we have H above the line. That's why we have D equals H. Now, let's quickly move to alternate angles. Please, if that place is not clear, please pause it, rewind it, and listen to it again. Now, we move to the alternate angles. Alternate angles are also equal. How can you get your alternate angle? Please pay attention before I list out all those things that are equal to each other. Now, alternate angle always forming Z. Whether C like this or Z like this. So whatever this place is, that's what this place will be. Whatever this place is, that's what this place will be. I take it again. Alternate angle always forming Z. Look at the Z, frontward, Z, backward. Whatever this place is, that's what this place will be. Whatever this place is, that's what this place will be. That is what we call alternate angle. Now, from what I've said, if you look at it very well, you will discover that when we talk about alternate now, permit me to quickly clean this place. So what am I saying now? Now, under this now, according to what we said here, alternate angle. So we have the example under this diagram is C, permit me, C equals E. And then we have B equals H. C equals E and B equals H. So the third property that I'm going to make conspicuous to you is what I call vertically opposite angle. Vertically opposite angles. Vertically opposite angle, excuse me. These, or let me say, vertically opposite angles are equal. Vertically opposite angles are equal. Now, let's go back to the diagram. Let's go back to the diagram. E.g., from the diagram above. From the diagram above. Now, let's go. Now, from the English word, when we talk about opposite, it means something facing each other. Do you understand? Now, we have here, if you look at this place is facing this place. 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 Please pay attention. A is not facing B. A is adjacent to B or B is adjacent to A. Do you understand what I'm saying? Please don't be confused. We are talking about opposite facing. That's what we are saying. So what we are saying here is that any angle facing each other is known to be vertically opposite angles and they are equal. So please take note of that. So what we are saying now is A equals what? God bless you. C. So B equals what? D. And then we have E equals what? G. And F equals what? H. So these are the three major properties of angle. Now we are moving to what we call theorems of angle. So give me a little time as I quickly wipe this thing up. Then we go to theorems of angle. Now it is theorem of angle. Now look at the board. We have a lot of theorems, but I just want to make 4 conspicuous to us. So as we move on, by the time we see some questions, I'll be introducing some things to us. But the 4 major ones that you need to know are already on the board. Now, let's move. We have the first one I'm going to make clear to you or conspicuous to you is what I call sum of angles in a right angle is equal to 90 degrees. Now, if you look at this place very well, this is right angle. You know, I've said it under the types of angle. You will discover that A and B are staying within these angles. So by the time you calculate this and this, it must give you 90 degrees. So sum of angles in a right angle is equal to 90 degrees. And the second one I'm going to make conspicuous to you is sum of angles on a straight line is equal to 180 degrees. I repeat, sum of angles on a straight line is equal to 180 degrees. E.g., A plus B plus C is equal to 180 degrees. So you can see that this is a straight line. So all the angles that is on this straight line must equal to 180 degrees. It must not be less than 180 and it must not be greater than 180. Sum of angle on a straight line is equal to 180 degrees. So we move to the third one, which says sum of angles at a point is equal to 360 degrees. I take it again. Sum of angles at a point is equal to 360 degrees. E.g., we have different types of angle here, but they are being put together. Now, if you look at it very well, we have A, B, C, D, E. You can see that it's forming a circle, and that is why when you are doing your statistics under pie chart, they will tell you that sum of angle in a circle is 360. It's the same thing as sum of angle at a point. So sum of angle at a point is equal to 360 degrees, and that's why we have A plus B plus C plus D plus E equals 360 degrees. And this fourth one is so wonderful. You need to pay attention very well. Sum of two interior angles is equal to one opposite exterior angle. I take it again. Sum of two interior angles is equal to one opposite exterior angle. Now, what am I saying? When we talk about interior, we talk about inside. And when we talk about exterior, we talk about outside. Now, the sum of these two angles that is inside triangle is equal to this one angle that is outside the triangle. Do you understand? So A plus B equals C. Do you understand now? So I'm going to quickly do the recap of the four theorems. Then we now move to the workings. Now, what am I saying? The first theorem that I make conspicuous to you, as far as this video is concerned, is what I call sum of angle in a right angle, which I said is equal to 90. I talk about sum of angle in a straight line equals to 180. I talk about sum of angle at a point is equal to 360, and sum of two interior angle is equal to one opposite exterior angles. Now it is time for workings. Now, the first question I'm going to give us is going to be according to the theorems given to you. Now, if you look at the board, they ask us to find x. And if you look at the first theorem, I told you sum of angle in the right angle equals to 90 degrees. So this is 90 degrees. Are you paying attention? So to find our x now, we have x degree plus 60 degree equals 90 degree. Why? Sum of angles. Sum of angles in a right angle. Do you understand? So the next thing is collect like times. Collect like times. And that will give us x equals 90 degree minus 60 degree. Therefore, x equals what? 30 degree. That's all. So you can see that it's very simple. Now, let's move to the second one. Here they ask us to find y. What is this? Very good. This is a straight line. And sum of angle on a straight line is what? 180. So we have y plus 100 degrees plus 60 degrees equals 180 degrees. Y, sum of angles. So you have to put the reason there. Sum of angles on a straight line. Sum of angle on a straight line is equal to 180. So we have y degree plus 60 plus 100. We have 160 degrees. So what's the next thing? Collect like times. So we have collect like times. Then we have y equals 180 degrees minus 160 degrees. So the moment you carry anything that is positive to the other side of the equation, it changes to negative. Then we have equals 20. So y equals 20 degrees. Now let's quickly look for x here. Here they ask us to find x. What is this? This is sum of angle at a point. Very simple. So for you to find your x, then you have x plus 60 degrees plus 80 degrees plus 100 degrees plus 80 degrees equals what? 360 degrees. God bless you. Why? You put your proving permit me to adjust the line. This is sum of angle. Sum of angles at a point. At a point. Then we have x. Then plus 60 plus 80. That's 140. 140 plus 100. That is 240. So now 240 plus 80. That is 320. So we have 320 degrees equals 360 degrees. Then collect like times. Collect like times. Then x equals 360 degrees minus 320 degrees. X, therefore, x equals what? 40 degrees. So that's all about the first three questions. So we move to the next question. So if you look at the question 4, you know, the more we move, the more we get some questions. But don't be afraid. It's very simple. Very, very simple. Now they ask us to find the missing angles. Now to find this is very simple. The first thing we are going to find is n. Don't forget when I was talking about the properties of angle, I talked about this thing. It's transversal. It's also known to be straight line. So it's a straight line and the name is called transversal. From here to here is 180 degrees. Can you see? So to find n now, we are going to say n plus 35 degrees equals 180 degrees. Why? Sum of angles, let me show it. Sum of angles on a straight line. You are allowed. So when you collect like times, it will be n equals 180 degrees minus 35 degrees. And what's that? What is our n? When minus 180, when minus 35 from 180, what do you have? You have 145 degrees. And that's all for n. Very simple. So for you to find your p, because we are going to find it alphabetically. So after n, the next alphabet that we're going to get is p. So for you to find your p is very simple. Look at the board. Go back. You can pause this video now and go back to your properties of angle. Now, if you look at it very well, there's nothing to do here than to prove your property. Now, for you to find your p, just say p equals n. Why? God bless you. Alternate angle. Alternate angle. So alternate angles are equal. Do you understand? So therefore now we have P equals what? 145 degrees. Because whatever n is, that's what P will be. That is alternate. Now for us to find our Q is very simple. Look at your diagram. Pause the video. Go back to your properties. Then you will know what I'm talking about. Now, Q without solving anything. There are two ways or many ways to solve this. You can say P plus Q equals to 180, sum of angles on a straight line. Or you can say Q equals to 35. What's that? Corresponding. So just make sure you understand the properties very well so that you can solve any question whatsoever under this angle. So our Q is 35 degrees. Why? Corresponding angles are equal. So that's all about question 4. So let's go to question 5. Now look at it. They ask us to find the missing angles. So the first one we are going to find is letter A. Now, please, I will advise you to study your properties very well. Study your properties very well. Now, to find A is very simple. A equals what? 125 degrees. Do you know why? God bless you. Alternate angle. Alternate angles. Alternate angles are equal. Now, whatever this place is, that's what this place will be. So to find our B now, we can now say A plus B equals 180 degrees. Why? Sum of angles. Sum of angles on a straight line. Do you understand? On a straight line. Do you understand now? So this is a straight line. Then we have our A is what? 125 is here. Plus B equals 180 degrees. We don't know B, it's B we are looking for. So the next thing now is to collect like time. So we have B equals 180 degrees minus 125 degrees. So what's the next thing? B equals 180 minus 125. That one is what? I'm waiting for you to give me the answer. You don't know it? Come on, give me the answer. So when you minus 125 from 180, what are you going to have? That's 55. Please let your brain be working, please. So now we move very fast. Now the next thing here also asks us find the missing angles. Now, what do we have here? Now listen. This question is very simple. Don't be afraid. The first thing you need to do is to study the diagram very well. Now, this line is parallel to this and is parallel to this. Do you understand? The moment you see this line, they are telling you that the lines are parallel to one another if it is more than two, one another if it is two each other. Now, look at this place. This is below the line. So whatever this place is, that's what this place will be. So if this place is D, this place is D. Do you understand? Now, this is your straight line. So for you to find D now, just say D plus 32 degrees equals 180 degrees. Why? Sum of angles. Sum of angles on a straight line. Are we there? Now, for us to do this now, the next thing for us is to do what? Is to collect line times. So we have D equals 180 degrees minus what? 32 degrees. Then we have D equals, when you minus 32 from 180, what are you going to have? That is 148 degrees. God bless you. Very simple. Now, the next thing is for us to find our E. Very, very simple. Corresponding is still here. Whatever this place is, that's what this place will be. That is corresponding angle. So, E equals D. Why? Corresponding angles. Please study your properties very well. Therefore, E equals 148 degrees. God bless you. So let's quickly move to another question because I want to solve as many questions as possible so that I can understand this angle very well. God bless you. The next question. This is the next question. Question 7. They ask us to find y. We have 30 degrees here. We have 152 degrees here. Now, don't forget, this line and this line, they are parallel to each other. And that is to say that this can still continue. And this can still continue. Like they used to say that parallel line can never meet. Now, this is a straight line. If this place is 152, what is this place? That's 28. God bless you. 28. Now, if this place is 28, now please look at the diagram very well. Now, this is a shape of triangle. Maybe I should quickly use the opportunity to tell you that sum of angle on the straight line and sum of angle in the triangle is the same thing. They are all equal to 180 degrees. So now, this plus this, that is 28 degrees plus 30 degrees, will give us what? 58 degrees. So by the time you minus 58 degrees from 180 degrees, what are you going to have? You are going to have 122. 122 degrees. Permit me, sorry, the diagram is very small. So now, don't forget, when I was talking to you under the properties, I told you corresponding angles are equal. So if this place is 122 degrees, then what is y? Y equals what? 122 degrees. That is what corresponding angle. So there's nothing much under that. Now, that's that. Now, God bless you. So let's move to the next one. Now look at this. I know you'll be surprised. What type of diagram is this? Very simple to calculate. So the first thing is N. Then you go to, okay, maybe we should first of all calculate F. Very simple. So if you want to calculate F now, it's very simple. This is a straight line and it's parallel to this. So don't forget, whatever this place is, that's what this place will be. That is corresponding. So F equals what? 112 degrees. Very simple. So to find your N is very simple. This is a straight line. From here to here is 180. So you have N plus 112 degrees equals what? 180 degrees. Why? Sum of angles on a straight line. Are we together? Good. Now, collect line times. N equals 180 degrees minus 112 degrees. So that one will give us what? When you minus this, when you minus 112 from 180, you are going to have 68 degrees. So, N equals 68 degrees. So once you have found N and you have found F, the rest is very simple. Now, the next one is P. What is your P? If you look at your diagram very well, go back to your properties. This is nothing but alternate. You can see the Z. Can you see the Z? So whatever this place is, that's what this place will be. So we have P equals N. Why? Alternate angle. Are we together? Alternate angles, and they are equal. Then we have, therefore P equals whatever the N is, that's what it's going to be, 68 degrees. So now to find our Q is very simple. You can say Q equals to this, alternate. You can say Q equals to this, vertically opposite. So maybe we should make use of Q equals F. Q equals F. And what is that? Vertically opposite angle. Vertically opposite angles. They are equal. Therefore, Q equals whatever F is, that's what Q will be. 112 degree. So this is where we are going to stop for today. So see you again. God bless you.